Yeah, good afternoon. Good afternoon, and welcome to Bangalore, right? And did you enjoy the morning session? Fantastic. I'm sure this afternoon we have very good sessions for you, good speakers, great stories that will energize you, and you'll have a great session, I'm sure. So, without getting late, I would like to introduce the first speaker, who is our Vice President of Vice President of Business Strategy and Marketing, Nicolas Mangon. And I have known Nicolas for a very long time. I believe the Revit platform, the transformation happened with the API that was developed for Revit. And the man behind that is Nicolas Mangon, right? And whatever you see today, the BIM, the strategy, the way of market is driving, the growth behind it is all because of that. And today I'm going to invite Nicolas to speak on future of making things in AEC. Thank you.
Thank you, Sunil. Yeah, it's been actually 15 years that I've known Sunil since we acquired Revit. One of the very first things I did was to build an API and then the structural products and then other products so we can really embark in this journey where we are today. So what I would like to do today is talk about, connect the dots from what you heard this morning from Pat, from our customers, and explain what this technology, machine learning, prefabrication, robotics, how it's going to impact the way you work today. But before I go into some of these details, one of the things that I want to give you, it's a big picture globally about why we do all of that. And if you look at the number of people on the planet today, we are about 7.5 billion people, and 3.5 live in cities. By 2050, so in 32 years, basically, starting January 1st, we'll be 10 billion people or even more, if you look at certain predictions, and we will be 7 billion people living in cities, right? So 7 billion people will live in cities. So what it means is we need to double the size of all cities on the planet in the next 32 years. So if you have conservative estimates, it's about building 1,000 buildings every single day the next 30 years. It's pretty huge number. And in India, actually, it's going to be about a little bit more than 400 million people moving to cities in the next 30 years. So we need to build, housing, hospitals and schools, which will create a ton of pressure on the construction industry. If you look at the productivity today among multiple industries, you will see at the bottom that in the last 20 years, the productivity remained flat in construction. It's actually the worst industry in terms of productivity gain that we've observed. The total economy grew about 2.5% per year, construction 1%, and manufacturing industries grew 3.5 or 3.6%. So we are definitely not growing, but we are also one of the largest industries in the world. We represent about 13% of global GDP. So we are a major industry. We are not growing. We are really laggards in terms of productivity. And there are a number of reasons for that. One of them is the fact that we are highly fragmented. So many, many different players, so architects and many, many engineers and fabricators and contractors, so highly fragmented. And what you see on the screen is really the process that one of our customers documented for us, just to explain the complexity of what it takes to deliver a project. The other challenge is the fact that we are not a digital industry. We are very much analog. And if you look at the investment in technology as a percentage of GDP in construction, it's about 1.2%. If you compare, manufacturing invests 3.5% of its revenue in technology. So basically, manufacturing invests 2.5 times more than us in technology. So we are a software vendor, so of course I'm going to say we don't invest enough in technology, but there's a direct relationship between how much we invest in technology and the productivity compared to manufacturing. So the opportunity is really to go digital. And the Boston Consulting Group published a paper actually not too long ago, and they say that if we go 100% digital, and we will never do that, by the way, I don't believe it, but if we were to go digital, we could save $1.2 trillion a year. The total GDP in the world for construction is about $10 trillion this year, right? So we could save 12%. And if you look at the margin of construction companies, you know, it's at best 1 or 2%. We could easily double or triple the margins if we start using manufacturing approaches to construction and use technology. And I'm going to talk about it. So for us, it's about building information modeling. And we started that journey about 15 years ago with the acquisition of Revit. And since then, we've seen wonderful projects. And here you have one that we saw this morning. It's a Museum of the Future in Dubai. It actually won the AEC Excellence Awards a month ago that we gave at Autodesk University, Las Vegas. Oh, we need probably to turn off the audio. So that's another example. It's the New Mexico airport designed by Foster. I was actually in Mexico. I was in Mexico just last week. Just a week ago, I was on a construction site. It's going to be one of the most amazing projects. It won the Excellence Awards for infrastructure project. Foster could not design this amazing airport without using BIM technologies. This project today has a capacity of 40 million passengers a year, and they are designing it and building it to increase to 120 million passengers a year. And they are targeting to have this project that will last for at least 1,000 to 1,500 years. So it's an amazing project, and they've been using all of the technologies around generative design, and are using also cloud-based technologies for the construction side. So we've seen a lot of projects in building, but also in infrastructure. Like this project here, it's the second largest or third largest infrastructure project in the world. It's the Grand Paris project. I'm actually from France originally, and it's made of 220 kilometers of new railway, and 90% of it will be underground. They're also building 68 new train stations underground, and they've used the full portfolio of technology to integrate both horizontal and vertical infrastructure. So BIM is working all around the world, and we see many, many customers. In many regions, it's the standard way of delivering projects. But what's next? So if you look at technology or era of disruption, every 10 to 15 years, there's a major wave, a major earthquake in terms of disruptive technologies. And 35 years ago, it was AutoCAD, moving from hand drafting to CAD. And many of you are still living in that world. That's the era of documentation. 15 years ago, we introduced BIM and Revit, and it was the era of optimization. We were building a 3D model and using that model for simulation, for coordination, et cetera, et cetera. But today, we believe with the cloud, we are entering a new era of disruption. And, very few are in this new era, and that's what I would like to discuss today. And what the cloud changes, it's really 2 or 3 things that are pretty important. So this morning we heard from Tatiana about infinite computing power. I'm not going to talk about this right now. But what I want to talk about is this idea of connected BIM. And what has changed with the cloud is you can put sensors or connected objects anywhere in the world. They are geolocated. And you have also a 3D model in the cloud. And you can build these real-time relationships between the physical world and between the digital world. So that's what we call connected BIM. And the simplest definition of connected BIM that you need to remember, it's connected BIM is BIM plus the power of the cloud. It's not a replacement of BIM, it's an augmentation of the capabilities of BIM with the power of the cloud. So that's connected BIM. And I'm going to talk about some of the trends related to connected BIM today. The first one will be around digital collaboration. It's one of the key things that the cloud will enable. And we've built, we brought to market in the last few years a product line called BIM 360. But what we did, we made a number of acquisitions. We also developed products, but all of these were not integrated. And what we've done in the last few years, and we just announced it a month ago in Las Vegas, we are bringing all of these tools together. And for us, the idea is really to build this common data environment where all the project information will live in one single place. And this information can be created by our tools, by our competitor tools, by our partners, by anyone. That's this common data environment. And we built it on top of our cloud development platform called Forge. And then imagine that on top of that, we can do all kinds of analysis. And Bureau Apple talked about some of this analysis. And then you have all of these different processes for design and pre-construction. And I'm going to show you some examples today. But let's talk about this common data environment. So one of the things that you will see this year, first, it's the ability to bring data from many, many different sources. So for instance, if you store your data in Box, you can bring and synchronize everything in this common data environment. You just go to the BIM 360 App Store, and you can connect your data coming from all different sources. The second one, and I think it's pretty important, it's what's the future of collaboration in design. And here, it's a preview of the next generation of collaboration for Revit. It's a cloud-based environment where architects and engineers will be able to work. And you will be able to forget completely about Revit files, RVT files, how you coordinate. All this information will live in a common data environment, and you will have a much more natural way to coordinate with other parties. And one of the key things that you see on top here, it's this idea of a visual timeline. And remember the process, the fragmented process. Many people change many things many times, during the iterative design process, and it's complicated. It's difficult to understand who changed what, where, when, and why. So, using this tool, you will be able to go on the timeline and bring any model, any change made by anybody, and do this visual compare or traditional compare. You will see the two models at the same time. And you will be able to go in 2D, 3D, and all the data will always be updated. You will be able to also compare multiple options. The second thing that we've heard from you is most of the time buildings have a civil part. And this environment will also integrate all the civil 3D data, all the land, the terrain, will also be part of this environment. So the same way we have collaboration for Revit living in the cloud, the data from Civil 3D will also be integrated in a single environment, right? So whether you're a civil engineer, an MEP engineer, a structural engineer, an architect, you will collaborate within this platform. And it's really based on this common data environment. Then the next piece, moving into pre-construction, will be to do all the clashes. And clashes can be done on the design phase, can be done in the construction phase. And most of you, I'm sure, have heard about Navisworks. And that's the next generation of Navisworks, where all the clash detection will also be performed. And the data will come from our tools, different tools. Any data that's brought into the project, you will be able to do clash detection. And remember, there's a timeline, so you will be able to go at any point in time and say, I want to do clash detection here, or 2 weeks later, or 2 weeks earlier, these type of things. And everything is based on the same data, on this common data environment. Then, one of the key things also that you need and your colleagues need is managing documents, whether you're on the design side, the construction side, or the operations. And one of the things we are doing is we want to digitize the construction side. We want to eliminate all papers. And we built this tool called BIM 360 Docs that will enable you to manage all the documents. Because when you think about the price is highly expensive for construction documents on the construction side. And also, it's never up to date, right? Because there are so many changes. So it's one thing that we also built. We eliminate the idea of drawings on the construction side. And you will be able to go from 2D to 3D. So construction doesn't happen in the office most of the time. It's on the construction side. So all of our apps are mobile. You can work on Samsung, on iPhone, any type of things. And here, one of the tools we had in the past called BIM 360 Field is also brought to this new platform, localized in many, many languages, on many, many platforms. And all the issues, all the changes that you have on the construction site are brought into this common data environment. So whenever there's a RFI, a change, everything is directly creating a RFI. The RFI goes directly to the architect. We can immediately see and track the issues and make the changes and approve them, all based on the same platform. And what you will also see moving forward, it's this idea of cost control. So managing the cost is, of course, one of the key, the key constraints for contractors, time and cost, and it's going to be also available directly on this platform. So all of these things you will see coming in the next year, this integrated platform for design, construction. And of course, everything can be pushed for operation and maintenance with different types of products. But the beauty, as I mentioned, is we have this common data environment. It lives on top of this platform called Forge. And let me show you an example of one of our customers. They develop a simple app that uses all of this data. And directly, for instance, the person in the office will say, you need to make this change, send a link, text the phone, use a VR tool, and then directly in the field you can experience it. So it's a good example of using the data in this common data environment, and then a third party could build this very simple app. And as I mentioned, with the press of a button, you will be able to push all of this data to different operations and maintenance tools. And we work with different partners like IBM and others. But we also have an app that's right now, it's called BIM 360 Ops. It's free, you can download it and see how you can manage your facilities with this tool. Everything based on this same and unique platform. So the next piece of that I want to discuss around industrialized construction, we actually heard a fantastic customers this morning that talked about the work they are doing with precast structures for schools and other types of projects. Well, there's definitely a big trend going on right now in the world. And with the productivity issue, we see a lot of companies actually researching, like the one we saw this morning, about how can we use manufacturing processes in construction. So you can see an example here from the US. Here's another example in Northern Europe. And this company here in Finland actually are manufacturing large pieces of buildings directly. And they can do it because they have big trucks, right? So if you have a big truck, you can put a building on a truck. They have big boats, so if you have a big boat, you can put buildings on the boat. And they have big planes. No, they don't. So I know. I wish they do, but they don't. Right, so But the point here, many companies, and this morning, I was blown away by the work they do, are using these processes. But what everybody wants to do, everybody wants to use really, these type of things, assembly lines that you see more in manufacturing. And we've done some early research, and today, 90% of the waste on the construction site can be eliminated if you work in a factory, right? The construction site is only 30% of productivity of what you see in a factory. So imagine that. And then safety. There are 2.5 times more accidents on the construction site than in a factory. So there are a lot of drivers that will push all of us to move things from the site to factories. And the way we are looking at it is we are looking at these three different types of segments. So what we call DFMA, which is design for manufacturing and assembly, what happens in the factory, and then the installation process. So I'm going to try to talk about each of these pieces. But the first one is the concept of DFMA will be quite simple. And basically imagine you design a model in Revit, and then you have a list of typical parts that you fabricate in a plant. And then Revit or some other tools will be able to segment automatically the building, all the facades, map it to specific libraries of parts, identify the common ones, and create all the information to drive the fabrication. We made an investment earlier this year in a company called Project Frog in the United States. So they are based in San Francisco. And they actually do something like that for all the partition walls. They develop factories all around the country. They also have a network of trucks that can deliver these panels, flat panels. And then they have a piece of software that they give to architects and engineers. And the software will segment the building in many, many, many sections. They press a button. If the panels are already fabricated, the truck can take them and deliver to the site where they are assembled. Or, based on the demand from multiple projects, the factories will build always the same panels. So it's an example of what we do. This other example here, it's a 3D example. The first one was more 2D. And here it's an example of a real project in the Nordics. It's a hospital. And basically, it's the same principle. When you think about a hospital, or a school, or a prison, or just looking at bathrooms in hotels, there are always, similar rooms. So what you see here is this idea of, you design in Revit, and then there's a tool that will identify all of the different rooms and understand, are they the same? Are they different? What are the opportunities to identify which one we should combine? And so it's one of the key things that we are working on. So taking a project and then identifying patterns within this project and then seeing, the ones that are quite different, how the software could be smart enough to take the rooms that are a bit different and make them all identical in the design, right? And here's an example. But, this morning we heard that, Autodesk has a lot of technology around manufacturing, and we are working to deliver, the same approach in terms of parts for all of the components and breaking all of these rooms in that case into different parts that could be ordered, that could be put together and assembled either in a factory or directly on the construction site. So these are the things that the customer this morning talked about, but that we are going to scale at a much larger scale. And talking about the factory, actually this morning we saw an example that will look a little bit like that. And it's fascinating, the similar vision that we have and that we are working on. It's really this idea of, a plant that will use some of the machines like in manufacturing and take, some of the components directly, from Revit that are segmented and then will be fabricated. And in addition to what we saw this morning, this machine will also add, doors and windows and electrical and also sensors for the future, light switches, all of these things will be brought, in a single, in this single machine. So because our customers design machines, we work with them to see how we can, they can extend, the machines they have for other industries and bring them, to the AEC world. And on the left, you see, how things will be tracked, because all of these components need to be tracked with the sensors, and I'll talk about IoT and the role of IoT in construction, and all of these objects will be tracked moving forward. The other thing that we are doing, and we heard about 3D printing this morning, it's we are partnering with this company called X3, and the previous example of factory was really mass production. But here, this example, it's mass customization. And, there's a point where, the cost of building a formwork or programming robots or creating, some of the assembly line we saw will be too high. And 3D printing of concrete will be the solution, at some point for mass customization of some of the concrete elements. But it's not all, because we also heard about robots. And remember what I said. So, we need robots to be geolocated, be connected to the digital world. And one of the things that we are working on is work with different companies that make robots, so they can take a physical model, if you will, of rebar, and then in that case, it's about welding some of this rebar. So more and more you will see, robots, that do this type of work in factories. And then moving into the site installation. So now that all of these components are built in a factory, it's going to be like Legos, and they will be delivered on site, and they will be assembled. It's very close to the vision that we heard this morning. So some of these components, precast panels will be delivered. Some of the modular rooms will be, placed inside, the building. So, but it's not all. So robots can work in a factory, but they can also work on the construction site. And I'm going to show you a couple of examples. So this one is the first example of robots that will be geolocated on the site. They will get the information from the model in the cloud and will start doing the layout on the construction site. So it's one example. The next one, Tatiana actually showed this example. And basically, it's the exact same idea. The robot is on the construction site, it's geolocated, it's connected to the model in the cloud, and then the person in the office uses VR, but it could be other systems, and that person can, through the cloud, control the robot. And these things are done today if you look at remote surgery. So today there are actually surgeons in India that operate people in Europe or in the United States. So it's this idea of remote construction. So it's about using robotics, VR, and drive remote construction. The next one is from our friends in Australia, and it's an example of a company, and there are multiple companies like that. Same principle, the robot or the truck is geolocated, connected to the model in the cloud, get the information of what needs to be built, and then you see what they do. We actually presented Sam, his name is Sam, this robot, at Autodesk University a year ago. So I like to joke about it. Don't tell President Trump that this machine exists, because he wants to build a big wall between Mexico and the US, and nobody wants to build it. So maybe if he buys a couple of robots, he's going to be able to do it. Right. So I'm joking. All right, so we actually developed a facility in Boston. So I'm based in Boston, who can tell. And to do research around robotics, so we incubate, startups. We have researchers from different academia, and then our own developers. And I invite, every one of you to come and see what we do. But we are taking our manufacturing expertise. We are taking our construction expertise with BIM to bring this together to deliver on this industrialized construction. And I think it's going to be key to deliver on the demand that we'll have to build 1,000 buildings every single day. So let's talk a little bit about IoT and the Internet of Things. And if you look at the, the platform idea, IoT, it's a different type of data, right? It's going to give us a lot of insight. And if you look at what different industries do, so let's look at manufacturing, they can put sensors on the frame of, a race car, for instance, to understand in real time stresses or deflections or any kind of things. That's what we want to do for construction. So today, many startups around the world develop connected objects. And I'm going to show you some examples. And why do they do that? It's because of this lack of productivity in construction. Because we don't really understand what's going on or what's not going on the construction site. And these companies instrument sensors to capture some of this information. And I'm going to show you 3 different examples. First, there is this company called Triax. They develop a device that you put on every worker, and it tracks if somebody falls, for instance. And as a result, it can send an alert, for response, to get an ambulance, based on the height of the fall, et cetera, et cetera. But this device, so we know where the person is. This device goes 2 ways. If there is an alert and somebody needs to be evacuated, or you need to say, oh, you need to leave this area, it's too dangerous, you can send a message, and then the person will get a vibration and will be evacuated. So it's one example of IoT technology in construction. This next one is a company called Pillar Tech that we incubated. And basically, they have sensors that they put on a site. And the sensors will detect things like dust or dangerous particulates or humidity. And they will be able to predict if, for instance, mold will develop on the construction site. So they capture all kinds of information on the construction site and send alerts. So for instance, if a pipe burst or something like that, they can detect and send alerts. This third company builds sensors that track equipment. In this case, it's a crane, and then track what the crane does. So what we decided to do is to combine all of this data in a single environment. So think about Navisworks today. Navisworks brings geometry and data from multiple sources. The problem of these tens of companies that develop technology is they all have different dashboards. They are different user experience, and people on the construction site will not be able to use 3, 4, 5, 10 different technology. So what we want to bring is all of the data in one environment using one interface, but also connect what the data do together. So what you'll see in the next video is, for instance, the Pillar Tech sensors will detect some dangerous materials in the air, and it's going to send an alert to the workers to evacuate the site. Another use case that you will see is the crane will move, and it's ready to hit a worker, so we can connect that the crane comes close to a worker, and then say, oh, careful, you need to move because the crane is coming, right? So that's what you see in this environment. So the red dots represent the sensors, and you can see at any point in time, for instance, the dust, during the construction. So, the heat maps will show you, different levels of dust in different regions, and you can go at any point in time and look at the dust in these rooms. Now we plug the Triax data, so the people, so we know where they are, and we trigger some dangerous materials here that will force the people to evacuate. So you can start tracking in real time people, machines, conditions on the site, and then, if you use these, factories and materials. And one of the key reasons why construction is not as productive as we want is because we don't know what's going on. We don't know if somebody walks 15 kilometers on the construction site to look for some materials. We will be able to do that. And here you can see the crane as well, so we can track where the crane is and connect the location of the crane with the people and trigger some alerts. So Tatiana showed the same example here around IoT. And in this case, it's real-time conditions on a living building. So we can see light, humidity, where people are, what they do. So it's really about understanding how people operate the project. We can understand, very precisely what are the different conditions. And it's very, very important to capture all of this. Because we spoke about generative design, right? So you can do generative design in two different ways. You can do the way we heard this morning, which is great. So, you start defining some parameters, and I'll show you some examples. Or you ask the computer to use artificial intelligence and machine learning to capture live data and learn for each of the projects to design, better buildings. And this one, it's another example of using IoT. So Alan and Shikran from Bureau Apple, presented some of the simulations. And basically what they do, they simulate what they think people will do. But imagine that people have sensors. You will know what they do. So you will be able to compare as design and as perform. And when you bring these two things together, you will be able to refine even more, the simulation models that we use for design. So the importance of IoT will be to capture data. And this data needs to be used to improve productivity on the site and during maintenance or operations of the building to really understand how we can use this information for better design. And that's the next part, key areas of machine learning. So we spoke about the common data environment. We spoke about getting better insight through IoT. And the last part of this presentation will be about analytics on the data. So we saw this example, the chair from Tatiana here this morning. And it's, it's a good use of, generative design, right? So multiple criteria, we'll design the best possible chair here. But the same thing can be used in AEC. And we've done, a number of research projects where, in this case, the computer can explore, tens or thousands or hundreds of thousands of situations for, the best facade. We heard about the Mars project in Toronto, where we asked our employees their preference, and the computer generated many, many different options. So this idea of generative design can be used on anything. And there is this customer called Van Wijnen in the Netherlands. I don't know if the video will start or not. I don't know if you can help me with the video up there. But what this customer does, they work on urban projects. That's the one before. Okay, let's try again. So the video apparently doesn't work, but this customer in the Netherlands, what they do, they use generative design to optimize a complete urban development. So they input criteria such as, end user criteria such as, the view from a house or, distance to a train station, etc. But they also put business requirements. And basically, the computer looked at the entire area and designed all of the different houses. And it's a good example of generative design. This one is a civil example that doesn't work either. But you can see it online. It's posted online. And basically, in this example, it's about optimization of grading. So instead of iterating many, many times, the computer will define automatically the grading. And now, at least we have a visual. Okay. I see that PowerPoint crashed. So I'm going to wrap in 1 second. So we just need to get the slides back up on the screen. But wrapping around the key technology trends. So we spoke about digital collaboration. We spoke about industrialized construction. We spoke about IoT. We spoke about machine learning. So these 4 technology trends will drive productivity in our industry. And that's the number one thing that we need to address. It's this idea of productivity. And the way we do it at Autodesk will be with building this platform, this cloud-based platform, based on top of Forge, which is our development platform, and enable companies like you, like our partners and ourselves, to build on top of it. So I think they are bringing the slide back up. Keep going, keep going, keep going, keep going. Okay, I think you can play it. Okay, so we're going to see very quickly the two videos, the Van Wijnen about the optimization of this neighborhood. So they looked at a number of criteria, the views, backyard size, but also business criteria. And the computer explored tens and thousands of options to come up with the best design. So exactly like we did, for one floor of the building, we can also do it for many, many different houses, right? So it's one of the examples. This one was about grading of a civil project. Okay, it's not working. And then this final example is what still built on the same platform. It's called Project IQ. And basically, it's looking at all of the information of a construction site. So it's looking at all issues, the time that every subcontractor take to resolve issues, looking at weather conditions, and doing big data analysis to understand that when you have these weather conditions, this type of project, if it's steel versus concrete, this type of subcontractors, analyze what the risk will be on the construction site. So I'm going to wrap right now. So we spoke about this platform. I think it's important that you follow what we do moving forward. So this cloud platform is available for, that you can take a look. And then you will see next year some of the BIM 360 technology that will be released. So I want to thank you. Have a great AU. You have a great lineup. Thank you very much.
Thank you, Nicolas. Was this all real? Was this all real? They can buy now?
Some of it.
So.